Good to be here with everybody and appreciate the opportunity. The project that I'm going to discuss today is called the Wando Welch Container Terminal. And this is something where we actually flew this site and we're building a data set for the entire facility that is going to be ported into an Esri geodatabase. Um, so, and again, I'm in business development. Carmen knows me. A few of you may have seen me at some of the WLA conferences. So I'll get started. I'm going to just quickly go over, see, there we go. Okay, what the outline is I have some facility facts. Then I'm going to talk about this is really a project team. It's not just our firm, but there's a whole team put together to work on this project. And then I'll talk about the geospatial aspect, the acquisition, the ground control, the aerial lidar imagery, and then geospatial mapping. Uh, but most people, analytical triangulation is a little bit of a automatic, but I'll just briefly mention that. Since we're going to do aerial lidar and imagery, we're doing a extensive feature extraction. And we also did orthos, and I'll go over the geospatial deliverables. And there are some existing data sets. And then we'll get into a little bit more of the meat of the Esri file geodatabase, feature data sets and feature classes, and how these are going to be attributed, the quality control, and there actually is a team site visit, which I'll explain towards the end, and I'll have some conclusion statements on the project. So let's go over some facts. Wando Welch is one of the largest terminal facilities on the eastern coast. This facility has 15 operational cranes to load containers on and off cargo ships. There are numerous smaller cranes on the site that stack and load and offload containers onto semi-trailers. This facility handles an average of 7,000 container transfers per day. There's 3,500 trucks that go in and out of this facility every single day on average. The facility is a major import-export hub for the entire southeast portion of the U.S. And Wando Welch is the largest of the South Carolina Port Authority's terminals. Now, the project team, Robert Hawks is the GIS manager for the South Carolina Ports Authority. He is driving the entire project. He's doing most of the upfront design of this for GIS applications. Patrick Engineering was brought on board to build the GIS and to go ahead and attribute the features that we extract. Dave Hurst is a senior consultant, Molly Freeman is a senior consultant for GIS, and Abe Krell is a GIS technician. And then for GPI Geospatial, you have Tyler Stentz. He is our project manager for the entire project, and I'm the business development manager. I basically monitor the progress of this site and make any adjustments that have to be made as we go along. And just so you know, this is not a completed project. This is a project that is physically in the works right now. We have compilers doing this project as we speak. Now, where is this? Wando Welch is literally located inside the Charleston Bay, South Carolina area. On the right, you can see the facility encompasses over 400 acres. It's a huge site. And due to the level of continuous activity on the site, as I mentioned, 3,500 trucks are going in and out of the site every day. It became clear that a aerial geospatial solution was the best and safest solution for the mapping and the geodatabase development. You'll also note on the right, the red outline is the the facility that we're working on right now. The blue is South Carolina Port Authority's um, headquarters. So we covered that, but we're not doing anything with that as of yet. Now, we did some very low-level aerial imagery, lidar and imagery acquisition. We had a local firm, survey firm, or engineering firm, very close to Wando Welch that we work with all the time, complete the control. We selected 16 points. You can see them. They're called CP number 1 through 16 on the map to the right. The sensor we used was a Regal 1560 double I, and that includes a phase one camera, which is built right into the sensor head. So you have simultaneous acquisition of LiDAR and imagery. We did a flight altitude of 1,800 feet above ground level, which is close to about as low as we can fly. We were trying to maximize resolution and also maximize the points per square meter. To accomplish that also, we did 50% side lap on the flight lines, and we had 7 flight lines, 152 exposures. The imagery was came out at 4.1 centimeter or 1.6 inch GSD, and the net LiDAR was 150 points per square meter. Very dense, very low altitude, very high quality imagery, as you will see in the next slide. These are some of the captures from the phase one camera. On the lower left, you can see 3 of the massive cargo ship cranes. These things are just huge. You just can't imagine. And in the center, you have transport containers loaded with tires for um, for excavators. And to gauge the size, if you look at the semi truck cab to the left on that image, each of those tires is almost as big as the cab of the entire truck. On the right is the entrance where every one of the trucks has to go through and get logged and get assigned to where they're going to go to on the site to offload and unload the containers. Now we go to the aerial LiDAR. Here you can see an image of 2 of the ships. This facility can take up to 3 container ships at one time. There's 15 cranes, and they usually have at least 8 to 10 of those operational at any one given time. On the right are those containers with the tires again. And this is all LiDAR data that we colorize from our acquisition. A few more just to show you the enormity of the site is here are all 15 cranes and rows of containers. And we're in both images. Now, we did an analytical triangulation, which is the process of expanding or extending and densifying control with minimal ground points. And when we did this, we noticed that the once we got the results back, the RMSE was very, very solid on this. In most cases, you're about 1/10 of a foot, which is really, really good. So. Now, the feature extraction. Wando Welch provided what they called a data element spreadsheet. And that's what you see. You see a portion of it to the right of the screen, the table on the right. They included, or Wando Welch GIS requested 142 distinct features to extract, everything that is important to them for facility management. And like I said, a sample portion of it is to the right. The feature data set grouping, which is shown under data class. Those are the main groupings: architectural structures, bathymetry, buildings, communications. Bathymetry did not have any features under it, but it eventually will. Individual feature classes were shown under feature. Like, for example, architectural structures, bollards, bunkers, duct banks, fuel tanks, all of these individual features we have to extract from the imagery and the LiDAR. And the feature type, which is, of course, point, polyline, polygon, is shown under type. And they also had a short acronym identifier for each of these features also. Examples of the features to be extracted, just so you understand. Bollards are typically those anchors that the big container ships anchor to when they're offloading and onloading. Duct banks are a series of conduits with either plumbing or electrical lines running through them. They align everything, they keep everything very very concise. High mast lights are, the tall lights that light the whole, all portions of the site. And then, of course, you have the truck scales on the far right. We also did orthophotography, and on the far left is the entire Wando Welch site in one Mr. Sid file. And then the center one are the shipping crates, all 15 of them. And then the right image shows the entrance, which is the top portion, and the exit. The very, very strong security at the site because, of course, they're getting international shipments and they need to know exactly who is coming in and who is going out. You don't get onto the site unless you have approval way in advance. The geospatial deliverables. We delivered a control report, orthos, calibrated unclassified LAS, bare earth LAS, 2D, and a highlight Esri file geodata database, and a signed and sealed project report. This is everything they need to be able to, for Patrick Engineering, to take our data and build it into the Esri file geodatabase. Or actually, we're building the Esri file geodatabase. They will be doing secondary services on it. Wando Welch had an existing AutoCAD file that they've been using for years and years. And there are intrinsic problems with it. There's no historical metadata. Pieces were added to this all throughout the last 20 years. Some data was surveyed, some wasn't. The majority of the data was named according to the data element list, that table I showed you earlier. And of course, the accuracy is not defined. Some things were just placed without any clear defined geospatial location. It can definitely be used, and it will be used by Patrick for attribution and identification of multiple features. Okay, now let's talk about the Esri file geodatabase. There are a total of 23 feature data sets, and they're structured according to the data element list. And I'm showing this again so you can see architectural structures. Here they are. These are all feature data sets, bathymetry, everything, every piece of equipment and utility infrastructure is within each one of these feature data sets. Each feature has multiple subsets. And what's interesting, as I told you, this project is ongoing. The feature data sets are still being modified to fit the client's requirements as we move through this project. The one thing you will note is the feature class Z unidentified features. This is something that we identified as very important. And I'll tell you why. Now we go to the feature classes. And of course, you have all of the individual features as a feature class under the feature data set. And I threw 3 of these on here, the architectural structures and buildings. And they will be once we complete the feature extraction in MicroStation, it'll be ported through AI scripts from DGN into the feature class name. Now, you'll notice that I show the unidentified features. No matter how accurate and how good we are, there will be points, polylines, and polygons that we just can't tell what they are. So we worked it out with Patrick that anything we can identify as one of these features, we will put into that feature data set and those feature classes, and then they will go and see and make every attempt to identify it and then port it into the proper feature class. All features will be attributed by Patrick engineering staff using existing collated source materials such as the AutoCAD file. We will not be defining any attributes for each of the elements within a feature class, but only define the shape, size, and geospatial location of each element. Patrick Engineering will complete and QC all feature element attributes with existing source material from the Wando Welch GIS Manager. Quality control, GPI geospatial has a very comprehensive QC QA program with checks during each phase and each step of the project to ensure that quality is built in throughout and within the final deliverables. We do have a QC manager review all deliverables before they go out the door. The lead GPI geospatial photogrammetrist, this was interesting, set up a channel in Microsoft Teams, an internal channel to discuss compilation techniques, work through procedures, address any issues, and to maintain consistency in the feature extraction process with all of our technicians are completing the compilation. Another QC measure was we have a weekly meeting with Patrick Engineering and GPI to confirm specifications, procedures, client updates, and ensure the production schedule is on track as proposed. Now, this was quite interesting. We, on August 15th, Robert Hawk invited Patrick Engineering and the GPI geospatial team down to Wando Welch for a site visit. This site visit was crucial to not only to tour the site, but to discuss the multifaceted requirements for a successful project and delivery of the Esri geodatabase. As you can see on the right, these cranes are just massive. The operational area of the crane is over 170 feet in the air. And we were actually got the honor of going up to the operational level. We didn't take the stairs. They do have an elevator. And you can see the two lower left images were images taken of the facility from that operational level. If you're afraid of heights, this is not the place to be. And in the center, that was our team, the 5 of us that went to the Wando Welch facility. And it was actually about one of the best things I've ever done on a project. Now, conclusion. I know I'm kind of gone ahead of myself here a little bit, but Wando Welch Terminal is a complex system that is always changing based on current technology and the import-export business. The use of a comprehensive GIS geodatabase will enhance the terminal staff's ability to implement and construct upgrades to the facility and improve productivity. As I said earlier, an aerial geospatial solution was the best and safest methodology to create the required feature classes due to the nonstop trucking activity at the site. And the success of this program will provide a clear and present model for additional terminal facilities within the South Carolina Port Authority. This project also validated the cooperation between the facility at Wando Welch, Patrick Engineering, and GPI geospatial staff to put together a successful project. And now we're at the end. If you want to contact me, my contact information is on the lower left. And if anybody has any questions, I'll hopefully be able to answer them. And I hear crickets. I know I went through that a little bit fast, Heather, but I know it's probably getting late in the day. People are getting ready to head out. But I hope this was something a little bit off the beaten track, and it gave you some insight into how geospatial data can be built into a comprehensive Esri geodatabase.
Yeah, yes, thank you so much. It's great to see GIS applied to industrial projects, and since we spend so much time in kind of natural resource world,
Yeah.
it's very interesting. Thank you.
Yeah. Yeah.